It's recording now. So this is the last section of the chapter, and we're going to do a little bit. We skipped chapter or section 5.4, but we're going to do this: more inequalities. Let's do this, and just listen. I'm just gonna go off topic. It's not really off topic, but just listen, okay? And don't freak out just because I give a little tiny story. It's not much of a story, but when you walk through that, shh, don't say anything. Don't say anything. Is that really needed? Was it really needed? You couldn't have waited. I know. That's the point. Exactly right. Did you need to while I was in the middle of talking? Did you really need to? Answer my question. Did you need to? Okay. Well, don't do it again. It's always a big deal. Anytime anybody does anything in here, it's a big deal. So if you go out the hallway by the science rooms, right out to the road right there. If you go to my modulars, you know where my modular building is. There's like a brick kind of paved way. It kind of cuts through. Well, I was here before they put that in there. Mr. Pusey actually put it in there. Okay, so like the sidewalk went like this. I'll just do straight lines for this. All right, and then the other sidewalk went like this. Okay, but my building is like right here. Okay, so before they put that pavement in there, okay, there's a sidewalk here, sidewalk here. Where do you think everybody walked? Right across here, which was what? Which was grass. Okay, would you agree? All right, so it got so worn, it got so muddy and ugly and everything else, they decided just to put down some pavement on there so you wouldn't walk on the grass. Now, why is that? Why did everybody walk on the grass to get to this point? Because it's shortest. That's right. Because, watch, from here. So, if you walk this way and you walk this way, and this is a right angle, okay, these two things are going to be what compared to, remember, we're doing inequalities. These two distances added up are going to be what compared to this distance right here? Less than? You're going to walk this way. So why would people cut through? Why would people cut through? Listen to the question, though. I know what you're thinking. You were thinking this is less than, but that's not what I was asking. I said, listen to my question. I said, if you walk this way and then you turn and you walk this way, which distance, or compare this distance right here, those two right there, compare that to this one right here. This would be longer, wouldn't it? Okay, these two distances would be longer than this one right here. And that's basically what our first theorem says. All right, so you see it all the time on campuses. When I was at Liberty, there were places where people would cut through all the time, and guess what they did? You come back from the summer, and guess what they did? They put a sidewalk right where everybody was cutting through. All right, you see that all the time. All right, I don't know why they didn't think about that beforehand, but anyway, that's what happens. So we have a theorem, and it's called this. It's called the triangle inequality theorem. Write it down. It's the triangle inequality theorem. I'm not going to write down the whole thing. It's probably in the book. I'm not really sure what book it's in, but let's take a look. It says this. It says the sum of the lengths of any two sides of a triangle. Now, earlier I said a right triangle, but really it doesn't make any difference. It doesn't make any difference. The sum of the lengths of any two sides, write it down. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So it's not just a right triangle. It could be an acute triangle. So let's just draw an acute triangle and just show you. So again, if I could draw an acute triangle without making it look like a right triangle, that probably will look pretty good. looks equilateral, but who cares? So watch. If I call this A and B and C, what this, what? Go. Watch. What does this theorem say? It says that the sum of the lengths of any two sides. So pick any two sides. Let's start with A and B. So it says the sum of any two sides. I could have picked B and C. I could have picked A and C. All right? Is going to be greater than the third side. So what's the third side here? It'd be C. So I could take any of the two sides. It doesn't matter. Okay? Any of the two sides, if I add them up, it's always going to be bigger than the third side. That doesn't even if it's a obtuse triangle. Let's draw a little obtuse triangle here. Right there. All right, and we'll call this DEF just to make it different. Now look at this. I could take even the two shorter sides, the D and the E, right? If I add up the D plus the E, it's always going to be what? Greater than the third side. And what's the third side? It's F. Even though F on an obtuse triangle would be the longest side, those two shorter sides will always be bigger than the third side. Okay, everybody got that? So the two shorter sides will always be bigger than the third side. That means any of the two sides are going to be bigger than the third side. All right. Do I want to do this next thing? Yeah, I'd probably better. Now watch this. Let's say I had let's say I did. Let's not just draw it just yet. Let's write something down. What if I had a triangle that had sides 6, let's say 5, 6, and 9. Okay? Could I make a triangle with sides 5, 6, and 9? Okay? Could I have a triangle with sides 2, 6, and 9? Okay? So let's do this. Now, I wish, do I have enough time? I got 15 minutes. Yeah, I got enough time. Let's go to GeoGebra, and I'll show you with GeoGebra. Okay? So I've got to change this. There we go. There's GeoGebra. I didn't practice this. I'm just thinking off the top of my head. I think this will work. So watch this. If I had a segment from here to here. Oh, I know why. It's because I'm using my pen when it does that. For some reason, when I use the mouse pad, it doesn't do that.
Yo, be quiet, guys. What are we doing?
I should have practiced this because I don't know if I can make this like a certain length or not. It says distance or length. Oh, I know what I can do. I could do this. I could just do that. And then let's make this 2. I think. Oh, I got to escape. Sorry. There we go. Let's make this. I'll tell you what. Let's just double it. What did I say? 2 what and 2 6? No, it was the second one. It was 2 6 and 9. Yeah. 2 6 and 9. Okay. Let's just double it. Let's go 4 what? 12 and 18. So there's 4. Okay. Let's do another one. And then what do I do again? Okay, find the distance or length. Let's make this one. What was the second one going to be? 12? Oh, I got to escape. Let's make this 12. Oops. Okay. And let's make another one. And what would the next one? 18? Oh, I don't know if I have enough room. You think? Nah, I think it's going to be.
It's probably about 15.
Oh, you know what I can do? I can do this. There we go.
16, I'd say.
It'd be 18, right? Is that what we said?
I think that's what 16.
Yeah, let's see. Let's make it out to there. All right, now I can do this distance or length. Guys,
Be quiet.
just stop and watch, okay? It's not just free time just to talk. What did I say again was 18? All right, let's make this 18. Again, I'm just trying this. We'll see if it works. So here's the question. Can I make a triangle with sides 4, 12, and 18? All right. Okay. Well, I'll tell you what. Let's just use this as the bottom of our triangle. Okay. And let's use this and put it right there. And let's move it up. I got to keep it 12 though. I got to keep it 12 though, right? Exactly. There's 12. Now watch this. Oh, sorry. I said 12 and I stopped at 11, didn't I? There. Oops.
Oh, because it would have to be more than 18.
Right. Cancel that. Now watch. Is there any way that I could connect this and that length before? No. What's the closest that I could bring this in order to make this a... Watch. If I bring it down like this, I think I can lock. I don't know. If I right click on it, just bear with me. If I hit fix object, I don't know. It's still, it didn't do anything. Well, anyway, I'll just keep it 12. Right? I'll get it really close to here. There's 12 right there. Still, is there any way from here to here is going to be 4? There's no way from here to here is 4, because if the whole thing's 18 and this is 12, look, even if I put it right on top of it, that still can't be a 4, can it? Okay, do you see that? It's got to be a 6. But it can't just be a 6. It would have to be bigger than a 6. Because if it lied right on the line itself, this right here would be 6, agreed? But that's not a triangle. In order to make a triangle, I'm going to have to angle it up a little bit like that. So this has got to be more than what? No. This third side. The third side. It's got to be, it can't be 6. Remember, it can't be 6 because if it lied right here, from here to here would be 6. But as soon as I bring it up, what happens to that length? It becomes bigger than 6. It's got to be bigger than 6. Would you agree? Okay. So let's think about it. If I have 3 sides of a triangle, can I just take any 3 random sides and make a triangle out of it? No. What has to be true about the two shorter sides? Not just equal, they got to be greater than, bigger than what? In this case. 18, right. So this has got to be 12. If this is 12, the other side, it can't be 6 because you wouldn't be able to make it, right? It has to just be bigger than 6. Agreed? Again, what does that mean? That means the 2 shorter sides have to add up to be what? Greater than the third side, or the biggest side, the longest side. Do you see that? Okay, so when I have sides of a triangle, let's go back to my other program right there. So let's go back to this. How do I check to see if I can make a triangle out of this stuff? I take the 2 shorter sides. So in this case right here, what are my 2 shorter sides? 5 and 6. So if I add those together, they have to be what? Bigger than the third side or the longer side. Is that true?
Yes.
Yeah. Is 11 bigger than 9? So can I make a triangle out of it? Yes, I can. That's the kind of question they're going to ask you on a quiz and a test and the homework. They're going to give you 3 sides of a triangle, well, possible triangle, okay, 3 lengths, we'll say, and you're going to have to look at it and say, can you make those lengths into a triangle? Can you on this one? Yes, you can. Okay. What about this one right here? You cannot, because you take the 2 shorter sides, you add them up. Now, it's supposed to be greater than 9, but is 8 greater than 9? No, it's not. So, oops, where are we going? All right, so is 8 greater than 9? No. So, can you make a triangle out of these 3 sides right there? No, you can't. John?
So what if the 2 is a 3? So what if it was 9 and 9?
Okay, that's a good question. What if you had 3, 6, and 9? Okay, again, let's do the test. Take the 2 shorter ones. Okay, so you take 3 plus 6. Is 3 plus 6 greater than 9? No. This is that situation where the 2 lines would like lie right on the third one, okay? As soon as you lift the other one up a little bit, it's going to make that second one longer, okay? So there's no way, because I can get that 3 and the 6 to lie right next to each other, right? Like head to head like this, okay? But as soon as I lift the one up, the other one has got to be longer, okay? So is this a triangle? So 3 plus 6 is not greater than 9, so no, that's not a triangle. It has to be what? It's got to be greater. So you take the two shorter sides. I would guess that most of the time they put it in order, right? Smaller, middle. But what if they don't? What if they put 10, 5, and let's do it like this. 10, 2, and 5, okay? Can you make a triangle out of sides 10, 2, and 5?
Wait, no.
I switched the order up a little bit. That's all I did.
The biggest side is still the biggest side.
The biggest side is still the biggest side. You're right. This is still the biggest side. So what do? What's the test? You take the two what? Two smaller ones, okay? Just because I went in a different order doesn't make this smaller, okay? So you take the two smaller ones, okay? Is that bigger than the third one? It's not, because 7 is not greater than 10. So can you make a triangle with 10, 2, and 5? No, you can't. Now, later on, settle down. I know this is super exciting, but you got to settle down. Later on, remember we did Pythagorean theorem? And we had a special triangle. I don't know if you remember this, but we had a triangle, and it was a 3, 4, 5 triangle. I don't know if you remember that or not. Anyway, we did. And so first of all, is this a triangle? Can you make a triangle out of sides 3, 4, and 5? What's the test? What's the test? You take the two smaller ones, you add them up, and you see if it's bigger than the third one. Is 7 bigger than 5? Yes. So yes. Now watch this. This really isn't in this section.
Yo, shut up, please.
I'll give it to you that it's Friday. That's the only reason I'm not writing anybody up. All right? It's ready. We're ready to go. It's at the end of the day. I get it. But you got to still settle in here. So look, yes, it is a triangle, but we're going to learn some other time later, because there will be a time where we do the Pythagorean theorem in here for real, okay? We just touched on it. It wasn't specifically taught to us just yet. But here's what you can do. You can actually tell what kind of triangle that it is. Not just that it's not just that it is a triangle or not a triangle. We can actually see what kind of triangle it is. I'll just show you real quick. I think it's kind of cool. I figured we'd just take the time now to talk about that. All right, let me see what else I got to do. Yeah, okay. Watch this. So let's look at this. Do you remember Pythagorean theorem? A squared plus b squared equals c squared? Okay. The a and b represent the two smaller sides. The c always represents the longer side, okay? So let's do it. Let's see what kind of a triangle this is. So if I go 3 squared plus 4 squared, does that equal 5 squared? It does. That's 9 plus 16. That's 25. Does 25 equal 25? Yes. So, listen. So when you have this, when a squared plus b squared is equal to c squared, then what kind of a triangle is it? It's a right triangle. It is a triangle. We already said it was a triangle. We said it's a triangle, and we can also see specifically what kind of triangle it is. We can also tell if it's an acute triangle or an obtuse triangle. So watch this. Here's a different version of the Pythagorean theorem. Instead of equals, if I put less than c squared, right there, this tells me that it's an acute triangle. All right, so let's use one of those numbers. Well, that's not even a triangle. Give me some numbers. Give me 3 numbers that actually is a triangle. Let's go 2. Let's go 2. Let's go 6. And let's go, how about 7? Okay? Now, these aren't going to work out real pretty, but that's okay. So first of all, is this a triangle to begin with? Yeah, take the two smaller ones. 2 and 6 is 8. 8's bigger than 7, so yes, it's a triangle. But let's figure out if it's acute or if it's obtuse, because it could be obtuse. How do you think you would know if it's obtuse? If it's equal, it's a right triangle. If it's less than, it's an acute triangle. If it's what? Greater than, guess what? It's an obtuse triangle. Okay, so let's watch. Let's watch. So let's try it. Let's see what this is. So I take 2 squared. Has anybody got a calculator with them? Actually, we should do this without a calculator. So let's take a look. What's this? 4 and what?
Yo, be quiet.
36, and this is 49. I shouldn't put equals. Why am I putting equals here? Guys, we are not finished yet, okay? Don't pack up. Look, we're still not finished. I don't care if the bell rang. Sit down. 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 So look, 4 and 36 is what? 4 and 36 is 40. Compare 40 to 49. What is it? So what kind of a triangle is 2, 6, and 7? It would be an acute triangle. So here's your homework. I don't have it written down, but it's on your lesson plan thing. So look at your lesson plans. Oh my gosh, guys are like a zoo in here today.